Hello Year 5 and 6. My name is Mrs. Mole and I'm here to teach you your maths lesson today, which I'm very, very excited about. This is lesson 17 within the topic of fractions. In your last lesson, in lesson 16, you were learning to simplify fractions by looking at an improper fraction and first of all simplifying that. Then, once you had the simplified improper fraction, you converted that to a mixed number. You were set these questions as some practice that you could do at home. So we're going to have a look at how you got on with those. So let's take one example at a time. The first example is 10/15 at 8/15. Now, when I look at these fractions, I can see that in both the fractions the denominator is the same, it's 15. So I just need to add the numerators, that's easy. So 10 add 8 is 18, therefore the sum in this fraction is 18/15. Now the second step, I've got to simplify this fraction. And what do we notice about this fraction? I hope, like me, you have spotted that it's an improper fraction. How do we know that it's an improper fraction? Well, we know because the numerator has a greater value than the denominator. At this stage, I need to simplify this improper fraction by identifying the highest common factor of 18 and 15. Now, using my times tables knowledge, I know that 18 and 15 is in the 3 times table, and therefore 3 is the highest common factor. I'm going to divide 18 and 15 by 3, and that is going to give me a simplified improper fraction of 6/5. What I need to do now is to convert the simplified improper fraction into a mixed number, and I'm going to do that with the help of this representation. So I know that 5/5 will make 1 whole. But I haven't got just 5/5, I've got 6/5. So I can make 1 whole from 5/5, and then I've got 1 extra fifth as the fractional part. So when I convert 6/5 into a mixed number, this is 1 whole and 1/5, 1 and 1/5. Moving on to the next example. We've got 3 fractions that we've got to add together here. So that might seem more difficult, but actually it's not, because again, all of these fractions have got the same denominator. The denominator is 10. So we're just going to add the numerators. We're going to add together 9, 8 and 7. And when we do this, we get a total of 24. So the sum of these fractions is 24/10. Again, can you see that this is an improper fraction? And why? Well, that's because the numerator has a greater value than the denominator. And at this stage, we're going to simplify this improper fraction by identifying the highest common factor. Now, looking at 24 and 10, I've identified that it is 2. So I'm going to divide both the numerator and the denominator by 2. And that is going to simplify to 12/5. Now, I can use that model above, the picture of the fifths, to help me here. I need to now convert the improper fraction into a mixed number. 12/5. So 5/5 make 1 whole. So I can make 1 whole. I can make another whole from another 5/5, and that's going to be 10/5 altogether. And then I've got 2/5 left over. So from 12/5, I have made 2 wholes and 2/5. So as a mixed number, 12/5 is equivalent to 2 wholes and 2/5. The final example, the numbers are slightly bigger, but again, it's not actually more difficult. 32/20 add 12/20. Notice that the denominators are the same, and therefore we just add the numerators, giving us a sum of 44/20. Again, we are going to simplify this improper fraction. Looking at 44 and looking at 20, I know that both of those numbers are in my 4 times table, and so I can use the highest common factor of 4 to simplify. I'm going to divide both the numerator and the denominator by 4, which gives me a simplified improper fraction of 11/5. At this stage, we want to convert the simplified improper fraction to a mixed number. And helpfully, we're dealing with fifths again. We've got 11/5. And I know from my previous question, I can use my knowledge there of 12/5. I know that I can make 2 wholes. That's going to be 10/5. And then I'm going to have 1/5 left over. So when I convert 11/5 into a mixed number, that will be 2 wholes and 1/5. I'm sure you did absolutely brilliantly with those practice activities. Great job. So we are going to take another look at the first example from your practice activity. So 10/15 add 8/15, and this was how we solved it. We first of all added the 2 fractions to get 18/15, which we've already said is an improper fraction. And at this point, we simplified it by finding the highest common factor, simplifying that to 6/5, and then we converted that to a mixed number. And we're going to call this method 1. But there is another way that we can express this answer in its simplest form, and we're going to take a look at that now. So let's call my method, the new one, method 2. We're going to use exactly the same calculation and we're going to start in the same way. We're going to add 10/15 and 8/15, and that's going to give us a sum of 18/15. Now at this stage, we know that this is an improper fraction and we're not going to simplify it. We are going to convert this to a mixed number, and we're going to use this representation to help us. We can see 18/15 here, and we know that 1 whole will be made up of 15/15, and we can identify that here. So we've got 1 whole, and then we've got 3 remaining 15ths, 3/15. So when I convert 18/15 as an improper fraction into a mixed number, this is 1 and 3/15. Now this fraction is not in its simplest form, and that's what we need to do now. We know that we don't simplify whole numbers, so we just need to ignore the 1 for the moment and focus in on that fractional part of 3/15. In the same way as we did before, I'm going to ask myself, what is the highest common factor of 3 and 15? And I think that we can see that it's 3. 3 and 15 are both in the 3 times table, and the numerator of 3 is a factor of 15. So I'm going to divide the 3 and the 15 by 3. And that is going to give us, remember that 1 is coming back in, and 1/5. So we've simplified at a different stage there, and that's called method 2. So let's take a look at another example using method 2 to simplify. This time it's a subtraction, but the steps are the same. Notice the denominators are exactly the same. So what do we need to do? That's it. We just need to focus in on those numerators, and we're going to subtract 4 from 22. 22 subtract 4 is equal to 18. So the answer to this, once we've solved it, is 18/12. And we have an improper fraction. Now, can you remember what the difference was now with method 2? What do we do at this stage? Do we simplify it, or do we convert it to a mixed number? That's right, we're going to convert it to a mixed number, and we are going to use this representation to help us. So we've got 18/12. How many 12ths will make 1 whole? That's right, it's 12 twelfths will make one whole, and we can see that here. So we've got one whole and we've got 6 remaining parts, or 6 twelfths left over as the fractional part. So I've now converted 18 twelfths into one whole and a fractional part, which is 1 and 6 twelfths. Is this our fraction in its simplest form? Can you remember? Have we simplified yet? No, we haven't, and that's what we do at this stage. So how do we simplify? We'd have to identify the highest common factor. Do we need to simplify the 1? No, we don't simplify whole numbers, so we're going to focus in on that fractional part of 6 twelfths and identify the highest common factor. We can see that 6 and 12 are both in the 6 times table, and 6, the numerator, is a factor of 12. So the highest common factor is 6. So we are going to divide both of them by 6, and remembering that one whole, which we didn't need to simplify, that now we have 1 and 1/2. That is our fraction in its simplest form, and we've done that using method 2. So I think you are now ready to have a go at solving and simplifying on your own, and you're going to use my method, method 2, to do it. So here is the calculation that I'd like you to work with. I want you to pause the video, have a go at that using method 2, and then we'll see how you get on. So, how did you do? You will have noticed, I'm sure, that the first step was easy. The denominators are the same, tenths, so we're going to add 13 and 9, giving us a total of 22 tenths. Now, what did we do at this point? Did we simplify it, or did we change the improper fraction into a mixed number? That's right, with method 2, we're going to change it into a mixed number from the improper fraction. And you may have drawn something like this to help you, but if not, it's here now. Now we're dealing with tenths, so we know that 10 tenths are going to make one whole. So how many wholes can we make from 22 tenths? How many groups of 10 tenths? Hopefully you've spotted that we can make 2 wholes, 2 groups of 10 tenths to make those 2 wholes, and then we have 2 tenths remaining or left over as the fractional part. So we have 2 and 2 tenths. Now I'm sure at this point this is where you said, I've now got to simplify, I've got to find the highest common factor. Of course, I think you will have remembered that we don't simplify whole numbers, so we just leave that for the moment and we focus in on the 2 tenths, the fractional part. Looking at 2, I can see that it's a factor of 10, and therefore the highest common factor will be 2. So I'm going to divide 2 and 10 by 2, and that is going to simplify to 2 and 1/5. So 2 and 2 tenths simplified in its simplest form then is 2 and 1/5. So we are going to look at both methods side by side. We've got method 1 and method 2, and we're going to use a very familiar calculation, 10/15 at 8/15. In a moment, I'm going to ask you to pause the video, and I want you to think about what's the same and what's different about both methods. So pause the video now and have a good think about that, or discuss it with somebody who's next to you. So what did you identify was the same, and what did you identify was different? Well, the same in both methods is the sum, that we have a sum of 1 and 1/5. What's also the same is that when we simplify, we use the highest common factor of 3, and therefore we divide by 3 to simplify our fractions. So what's different? Well, hopefully you thought about when we simplify and the order in which we do things. So in method 1, with 18/15, which is an improper fraction, we simplified at that point to get a simplified improper fraction before converting to a mixed number. Whereas in method 2, with 18/15, At that point, we converted to a mixed number, and then we focused in on that fractional part and we simplified at that point to get 1 1/5. So well done for identifying those similarities and differences. And I guess the next thing to consider is, when should we use each method? When's it best to use method 1 and when's it best to use method 2? And that's a tricky thing. It's not an easy answer, and I think sometimes it depends on the numbers. And so we're going to have a look at another couple of examples to try and reason that through to decide when it would be easiest, most efficient, most accurate to use one method or the other. So we are going to look at a calculation, and we are going to think about and consider which method would be easiest, most efficient to help us to simplify. So 58/30 add 13/30 is 72/30. Now the first thing I think of is that those numbers are quite large, and at the moment I'm struggling to think off the top of my head of a common factor of 72 and 30, the highest common factor. It's a bit tricky. If you could do that, that's fantastic. But my gut feel is that I think I'd like to convert 72/30 into a mixed number at this point. So I'm going to use method 2. So our whole will be made up of 30/30. So I'm going to ask, how many groups of 30/30? How many wholes can I make from 72 parts, 72/30? And I can make one group, 30/30, and another group that would be using 60/30, and there would be 12/30 remaining as the fractional part. So I've made 2 wholes and I've got 12/30 remaining as the fractional part. Now these numbers feel a bit friendlier. We know that we don't simplify whole numbers, so we can just ignore the 2 for the moment and focus in on that fractional part. And they do feel friendlier, 12 and 30. When I look at those, I know that they are both in my 6 times table. So I'm going to divide the numerator and the denominator of that fractional part by 6 in order to simplify. And remembering my 2 wholes, that means that my fraction simplifies to 2 2/5. Well done if you use method 1. I felt that method 2 would be easier for me, and so that is the way that I simplified it. So again, we're going to look at a particular calculation and decide which we feel would be the most efficient, the easiest method to use in order to solve and simplify this calculation. So we've got 83/14 subtract 6/14, and that gives us an answer of 77/14. Now straight away I think that I can identify the highest common factor of 77 and 14. Those numbers feel a bit friendlier, and have you spotted it? It's 7. So I'm going to use method 1. I'm going to simplify at this point. So thinking about the highest common factor being 7, I am going to divide both the numerator and the denominator by 7, and that is going to give me a simplified improper fraction of 11/2. At this point, what have we got to do? Yeah, we've got to convert into a mixed number. So I've got to ask myself, how many parts, how many equal parts is my whole made up of? It's made up of 2 equal parts. So how many wholes, how many groups of those 2 equal parts can I make from 11/2? So I can make 5 wholes out of 11/2, and that's going to be 10/2 with 1 remaining half left over. And therefore, when I convert 11/2 into a mixed number, it is 5 1/2. So in this case, method 1 proved to be quite efficient. So here are the practice activities that I'd like you to have a go at before next time. So what I want you to do is to look at these calculations and use method 1 or method 2 to express the answer to these calculations in the simplest form. But what's really important here is that you consider why you've picked those methods and you are able to explain your choice. If you're not sure, perhaps you could use both and consider which one felt easier, which one felt more comfortable. But remember, the really important part is being able to justify why you picked method 1 or method 2 as the most efficient, the easiest, and which one you'd choose again. If you have time and are ready for a challenge, then there's a challenge at the bottom there of the slide. So I just want to say thank you so much for working so hard in today's maths lesson. I've really enjoyed teaching you and I hope that I see you again very soon. Bye for now.